Hi everyone. This video is going to be about GPS modules and getting them to work with Arduino. Now I've had this module for a long time. It was sent to me by a company called Reyax, and this particular one, the model is RY825. So it's quite a peculiar looking thing. As you can see here, there's like an aluminium top on there. It's almost like a sticker or something. It's a strange looking rivet or something there. I'm not exactly sure what that's for. And then there's either a plastic or a ceramic shell over the top of what I assume is a module, although maybe not. And then here we've also got power and GNSS. From memory, GNSS is Global Navigation Satellite System, and basically it's a collection of various different companies' satellite constellations, if you like. So the EU has a constellation of satellites, the US has one, Russia has one, and China has one, and they each consist of different satellites. And the idea being, of course, that we can use some triangulation methods, arithmetic, to find out where we are based on the position of different satellites. So yeah, it's quite a clever thing, and of course, if I've not already mentioned, the idea is that with a GPS module like this, it can tell you where you are with very, very good precision on the Earth, and it can actually tell you a lot more than that as well, but if we just keep it simple, and we'll just stick to that. So the pins, we've got int, VDD, TXD, RXD and GND, and int stands for interrupt, but we won't be using it. Then we've got VDD, which is plus voltage, which I think it's plus 3.3, I think. We've got TXD and RXD and ground. Ground obviously goes to ground in order to complete some sort of circuit in order to power the thing. So if I just quickly talk about TXD and RXD, those of you who are familiar with microcontrollers are aware that pretty much all microcontrollers have these pins TXD and RXD, and they stand for transmit and receive, and they are part of a protocol called serial communication. And serial communication has an out pin and an in pin, and it receives serial data. And maybe you'll find it's a little bit peculiar, but this actually has a TXD and an RXD as its main communication protocol. And that makes things a hell of a lot easier in a lot of ways. Anyway, let's look at the back of this. And let's have a quick look to see what we can see. So there's a cell there. Presumably that's to power its, to power it in some way. Maybe when it's disconnected it powers an RTC or something, I'm not too sure. There's a chip here, which is labelled Z0EM8G, which I don't know what that is, but 8G sounds like 8 gig, but I don't think it will be. We've got another chip there, YF04E, which I don't recognise, and then we've got some more little chips there. And I think if one of these isn't a microcontroller, there'll be a microcontroller in here in order to send and receive the serial data. Anyway, so that's enough about the module. I'll actually go over to the computer and just show you the guide so you can see it for yourself. But the main thing I want to do is to wire this up, code it, and then show you the thing working. I told you that I'd look at the guide, so here we go. It says here that it works with GPS, GLONASS and Beidou, which I believe is the American constellation, the Russian constellation and the Chinese constellation of satellites. Down here it says that it works with both, and it says that it works even in harsh environments. So like the previous Reyax module that I checked out, it was also a very good quality one. I don't know if you guys remember the transceiver, but if you haven't looked at the transceiver one, go and have a look at that, because that's a very impressive module with a very high range. Anyway, it says about battery backup and various other bits and pieces which make it more useful. And then it goes on to mention about different versions. And I've actually got this version here, which is the 1.8 to 3.3 level shifter version. And it doesn't have the flash, which this one does have the flash. So if we go down here and look at the schematic, it says that VDD is plus 3.3 to 5.5. So in other words, it's a 5 volt device. And then over here you can see that you can use SCL and SDA, which are I2C. So not only is it serial, it's I2C too if you want to use it that way. And then it's got a pin out here, which we don't need to look at the moment. Another few different bits and pieces, which again is not really necessary at the moment. And then it's got some, some figures. So typical 5 volts, and then the current is 40 milliamps. The TXD and RXD DIO, which I think is that data input output, is 3.3 volts. But it says here the operation voltage is 5. The baud rate, it says, is 9600, which is configurable. Then the I2C voltage and various other different bits and pieces, which may be of interest to you. So software configuration tools, it's got all these configuration tools, but to be honest, early stages, if you just want the thing to work, you don't need to bother with any of that. Because particularly the one that I've got is already configured anyway in a default way, and it's good enough for what I want to do. There's some measurements there. Again, I didn't use that. And then we've got different things here. So about the logic I/O voltage for different modules. So it says here for mine the logic I/O voltage is 3.3 volts. And there you go. So as is usually the case with these sorts of modules, I get the modules, I try them out, and I usually think, oh, that's quite interesting. And then I think, how am I going to make a video about this which is interesting, a little bit fun, and above all easy for you guys to follow and to replicate. And this one was no exception, of course. I still thought about the 3 things, but this one was very difficult. I struggled to make this video, and of course the reason is because getting it easy isn't so easy for me to do. And the reason for that is because to test a GPS module you need to be able to move around, and if I keep it simple and I connect it to my computer, of course I'm limited by a wire, so it's not so easy. Now you could think, alright, well I'll connect it to a laptop and then just walk around the garden or walk around the streets, but I'd feel like a bit of an idiot walking around the streets with a laptop and holding this thing in the air. So it took me a while, and then I eventually figured out a way in which I could demonstrate this, keep it relatively easy, and for it to work. So at this point now you might be thinking, well, this looks a bit extreme. All I wanted was a simple video to show me how to use this. And don't worry, I will show you that. But there's a reason why I've got so many components. And the reason is because this GPS module here tells this where we are, right? Because we're going to be in the car or walking or whatever. This is going to have to tell this where we are. But if it does tell it where we are, what use is that to us, It might say you're here. Well, it's no use to us, because we can't actually see it, can we? We can't actually see what it's saying to that. We can't verify if it's working or anything. So the first thing I've done is added this LCD. And what's going to happen is that when this tells this where we are, the Arduino is going to print on the LCD where we are, and that's the first thing we need to do, of course. And that will allow us to verify if the thing's working, because the number will change. And we could also just type the longitude and latitude into our phone and verify that it is accurate. Okay, so that's why I've added the LCD, and it's actually not that hard. I did a tutorial a week ago in preparation for this, and it'll show you how to wire and code that up. I probably will just go over it in a bit anyway, because it's very simple, but that's why I've got that. Now the other thing is, I've got, as you can see here, an SD card reader. Now I don't know if you can see that, you should be able, yeah, there you go. There's an SD card reader, and again it's very simple. And the reason we need the SD card reader is because I might be in the car, the GPS module might be telling the Arduino where it is, and the Arduino will print on here where we are. But when I'm driving in the car, how can I verify that this data that's on here is accurate? I can't, because I'm driving. So what I want it to do is I want it to store data on here in a text file on this little SD card here. If I just pull it out and show you, I want it to store it on there, a little 2 GB SD card. And when I get home, I want to get the data off it, I want to put it into some sort of web service, and I want it to map out where I've been like that. So that's why I've got that. Now the other thing is this little LED here, and this is an RGB LED, which isn't compulsory. But the idea of this is that when it successfully writes to that, I want it to blink green. If there's a failure, I want it to blink red. And again, because I'm going to be in the car, I need some sort of indication as to whether the thing's working or not. So, that's the idea. Now, I'm just going to show you how it's, well, I'm going to go through how it's wired up, and then I'm going to show you the code, and then hopefully I'll be able to test it out. So the Reyax module, the RY825 GPS module, you plug the VDD into 3.3 volts, okay? Then the TXD, I've plugged it into D4. And I'm using D4 because I'm going to use software serial. Okay, so software serial as opposed to hardware serial. You could actually use hardware serial if you wanted to, but on this Nano it's just simpler to use software serial. But again, I'll show you how to deal with that later. The RXD is going to go to D2. Now there's a word of warning here. Really, that should go through a level shifter or a resistor or probably even a voltage divider. In my case I haven't done it because it seems to be 5 volt tolerant anyway, but ideally that should go through a voltage divider. Then I've got GND, ground, which gets plugged into ground of course. Now I didn't want to dwell on it too much, but this here for the SD card, now it depends on the way you want to wire this, but essentially you have chip select, which I have to, where do I have it? To D5. I've got serial clock, which should go to, is it 13? Yeah, serial clock to 13. I've got Mosey, which goes to, let's have a look, in my case 11. I've got Meso, which goes to D12. I've got VCC, which goes to 5 volts. And I've got ground, which of course goes to ground. Now the LED, I've got that pushed in here, and I've got the pins set to 6, 7 and 8, and the cathode goes to ground. Now in the LCD here, I assume you could probably work this out for yourself, but I'll just pull this out. I've got ground, VCC, SDA and SDL. And SDA and SDL go to A5 and A4, and of course VCC and ground go to their corresponding pins too. For those of you who don't know, SCL is actually A5 and SDA is A4. So I'll just plug that in there. So now it's time to go over and look at some code.